Hi everyone, welcome back to my channel. Today we're going to solve shortest common super sequence, which is a hard question in the lead code. Uh, Let me read the question. Given two strings, written the shortest string that has both string 1 and string 2 as a subsequence if there are multiple valid strings written any of them. A string is a subsequence of string t if deleting some number of characters from t possibly zero result in a string s. Okay. Uh, let's see one example first. We have two strings a, b, a, c, and c, a, b. According to the question, we need a string like the minimum length string we have to get such that the actual the two strings should be a subsequence of it. If you see in this one, uh, ABAC, which is present here, and if you see CAB, which is also present here in the first part. So the second example is like both the strings are same, so we need only one string. Uh, Uh, so the way to approach this problem is like there were so many possibilities. The way we can do is let's say we are on this part and we have some pointer on this string and we have to let's say both the characters are same. We can for sure include that character in the result. And if the both characters are not equal, there is now we have two choice. Either include one character from first string or the second one from the other one, and we move forward. Likewise, we reach till the end, and whatever the leftover, we will be appending to the result. So we will be having s according to the question, we need a shortest common one. So among all these things, we need a shortest one. We see similar problems like LCL, longest common subsequent, those kind of questions. And we can solve in those approach, but we have to store the result instead of length in it. First, we will try to, let's say, in some way, if you are able to find the minimum, the shortest common super sequence length, uh, uh, will that helpful to build the actual string out of it? Uh, we can use a DP approach to solve this one. I'll try to code I'll try to get the length, the shortest length of super common subsequence first, and I will see how we can achieve the actual uh, uh, shortest common super sequence from the table, maybe. So let me find the question first. Here, let's see the constraints also. If you see the length is 10 power 3 and it only consists of lowercase English letters. Uh, to begin with, initial, I'll get the size of the each string. Now I will define a DP state of we'll take one extra one. So let's say this DP represent ending at I and ending at J, like one pointer in the string one and another pointer in string two. And what is the common shortest common subsequence? Let's say it will store this value in this one. Uh, Initially, let's say if there is even let's say uh, for string S1 of length 0, string 2 can be like length of its S2 or vice versa. If let's say if S2 if length 0 will be S2 of length will be the shortest common supersequence. So maybe we'll initialize those first. So size one plus which will be a row. Basically, this means that uh, so here we're taking zero length of string 2 for a string length of 0. The answer will be whatever the string length that it will be the shortest one because we just need to add this string to the result. And similarly, we can do it for column as well. The other way, it's like yes, and we do so for length of string 1 0, it will be like length of the string 2 will be the shortest common supersequence. So which will be this one. So basically, this means that S1 is like, let's say A, B, C, D, and S2 will be 0. And for length 1, it is 1. For 2, it is 2. 3, it is 3. And for empty string. And same way, for S1, this will be empty and this will be some cap. So this is the way. This will take care of the initialization base case. Now, what we gonna do is like we're gonna start with length 1 because we already handled empty cases. I put this plus and all around. Okay. Now, what we gonna do is uh, if str1 dot caret row minus 1 because it is one based index here is equals to str2 dot caret row minus 1. If both are equal, what we gonna do is maybe of column is equals to 1 plus dp of row minus 1 plus column minus 1 will be the minimum one. Else, uh, dp of row column is equals to uh, we need to include one character. So 1 plus uh, what is the shortest? so far, which is either math dot min of dp of rho minus 1 or dp of rho column minus 1. Uh, so if it is not equal, we'll either include one character from either of the string, and we'll take the minimum out of the whatever we've chosen. Excuse me. Now, by the end of it, we will be having the length of the shortest common supersequence. Uh, now, if you see the DP table, uh, the DP of will be having the minimum shortest length character. What we're gonna do is we'll uh, we will be starting from this point, and since we need the shortest seek actual string instead of length, uh, we'll be starting at the bottom right of the DP table. And if the characters are equal, we'll take that and move towards the diagonal because we'll have to solve the other one. And if it is not equal, let's say, what we can do is we can either take one character from it, either character from any string, and move towards wherever the minimum length of the string is. That way, by traversing it, we will be having the actual superstring, which is shortest one. So let's say will be rows. We will be starting at the diagonal, right bottom diagonal one, and while row less than 0 and column less than 0. Now what we're gonna do is str1 str2 make it -1 because it is 1 based. If it is equal, we'll need to we'll capture the result in a string builder. We can keep appending one character at each time. So let's say this will show the result. Uh, in the final, we'll return result. Since we are starting from the behind, um, we'll have to reverse this result. Then we'll convert into string. Reverse. Okay. Now what we gonna do is we'll keep, since these are equal, str1 dot caret rho -1. We'll decrement. Since both are equal, we choose in a character at that position, and we'll move towards the diagonal part. Uh, this will be, sorry, this will be result. Else, what do we do now? Uh, what we can do now is we'll check uh, dp of rho -1 less than if it is if we have this, if this has a shortest length, then we'll choose one character from string one. Sp dot append str dot one caret row minus one, and we'll do row minus minus. Okay, and we'll be doing the other way around. If not, uh, we will be having this part, and we will be doing column minus one. This will be resolved. Now, by the end of it, we might have some left over, whether we have still some characters to process either of the string. I will have to handle that. Since row is less than 0, what we're gonna do is result dot append of str1 dot caret row minus minus. Uh, if some characters are present in the other string too, we'll be appending str dot caret column minus minus. Okay, yeah, I think uh, it will be most of the part is good soon. Here we don't have those, so it should be size 1, size 2. I think it is better to name it as rows and columns, as we are representing rows as a string 1, and columns represent the string 2. Uh, size 2, there is some error here. We'll try to run for sample test case. I think it is failing. Okay, something is wrong. We are getting length of the string here, and we created a DP table. Uh, okay, this is also fine. Since we are decrementing it, it should be greater than 0. I think that is the issue here. Uh, same here. We got some extra character. No, something is wrong. We are appending here. I think that should be. Yeah. This ratio. Yeah. Let's try to submit this solution. Yeah, accept. Coming to time and space complexity, uh, we are getting length here, and we are running one loop of size 1. And let's say this is n, and this is n, size 2 is, so n plus n so far. And we are running two loops, which is n times n, and we are doing some constant operations here. So far n times n, and we will be here we are processing row column. So at most we will be doing n plus m here, and we are appending it the character which is we are appending at the end, so it is a constant time. So overall here it takes n plus m. If there is any leftover, it will be that either n or n. And we are doing a reverse. So at most it will be n plus m plus we are converting, so n plus m. So overall it will be like n times, we go n times m, and space complexity will be we are using an integer TPRF size n plus n, and so it will be n times n, and one string n plus n for the result. So it will be big of n plus n. So this is the time and space complexity for this solution. This is the hard question in loop code, and it is a very good question. And the same approach can be done. Like if you know if you see the longest common subsequence question, so it is of that same pattern. The thing is, we first find the length, shortest length, and from there we retrieve the actual output, like the actual shortest string. Here using a two-pointer approach. So I think it is a very good question. Like it covers DP and two-pointer approach, and that's it for today. And if you like this question, please like to share and subscribe to my channel. And thank you so much for watching.